Hello, everybody, and welcome to lesson 10, chapter 10-1. Lesson 1, we're skipping some chapters. You need to have the second textbook. This is on multiplying powers with the same base. So first up here, let's write and explain what a power is. So a power looks like this. You have a number raised to a power, let's say 3, that you say 2 cubed or 2 raised to the third power. And so the bottom number is called the base. And the top number is the exponent. And the whole thing is called a power. The exponent tells you how often to multiply the base by itself. So 2 to the power of 3. Notice the 3 is much higher than the 2. Please don't write 2, 3. That's not it. It has to be 2 raised to the third power. And what that means is that you multiply the base 3 times. And that would be 8. So a lot of students want to multiply 2 times 3. Is 6. That's wrong also. Okay, it's the base multiplied together 3 times. So this is what we're looking at, and we're looking at powers with the same base, correct? So the base has to be the same. To multiply powers with the same base is our objective. Multiplying powers with the same base. You usually want to highlight those things. Those are the important parts. So what I want to have you write, and this is very important, so make it big and make it so you can read it and maybe highlight it. Here's the rule. In math, it's called a property, okay? When multiplying, powers with the same base, what you do is you simply add the exponents. So I'm going to have you make sure you have that big. This is the sentence you kind of have to remember. Remember how you had the 2 special triangles and you had to remember the relationship between the sides. Well, it's kind of the same thing. You want to have that in your head. Here's an example. Let's say I'm going to use a different base, 3 squared, 3 to the power of 2 times 3 to the power of 5. I'm just making up numbers here. You notice you have the same base. This is 3 and 3. You write it one time and you add the exponents. So that would be 3 to the power of 7. And that's it. So here's another example why it works. 3 to the power of 4 is 3 times 3 times 3 times 3 times 3 squared is 3 times 3. 1, 2, 3, 4, 5, 6. So you have 3 to the power of 6. So this kind of explains the whole story, why it works. Notice that the sum of the exponents in the expression 3 to the power of 4 times 3 to the power of 2 equals the exponent of 3 to the power of 6. In math, in algebra, you're going to a lot of times see general rules using letters like a to the power of a number m times a to the power of a number n is simply that base a to the power of m plus n. So you can use any number for m and n and it'll work. Okay, this is called a property or rule. Okay, remember the base has to be the same. If the base is not the same, you can't do it. All right, so that's your overview. Let's look at the next page. By the way, we're on page 595. Okay, I should have said that in the beginning. So on the next page, we're going to do some examples. This is page 596. What is the expression written using each base only once? Well, the bases are the same, so I have to check, right? You always want to check. So I add the exponents. So it's 8. You write the base once. 3 plus 6 is 8 to the 9th power. Pretty easy. 0.5 is your base. And does it match? Yes, these two bases match. Okay, bases match. So you have the powers, the exponents need to be added. -3 plus -8. That's -3 plus -8 is -11. So if you want to make that a positive exponent, I'm going to say or, you have to write it over 1, under 1. That makes it a positive 11, which is what we usually want, but this is okay for this scenario. And C, check if they have the same bases. Yes. So you write the base one time. And now you have to add the exponents. -3 plus 2 plus 6. So your base is 9. -3 plus 2 is -1 plus 6 is 5. Oh. Okay. Okay, add the exponents. Now let's look. Using the base only once. Okay, we're going to do these two on the bottom here. So I check the base. Yes, it's the same. Check, right? Yes, same base, add exponents. You notice we're multiplying these powers. So the rule is when you multiply these powers and they have the same base, you add the exponents. I'm just giving you a little review what you already heard. So you rewrite your base one time. 12 plus 5 is 17 plus 2 is 19. Okay. And here, 9, 9, 9. 6 minus plus -4 is 2. So that's 9 to the 0, which is 1. 6 minus 4 minus 2 is 0. Very good. So that's kind of the simple stuff. And we're going on page 597 to the top. It says up here, when you always want to look at these shaded little sections, they are very important. When variable factors, variable meaning x's, do you see how you have variables? When variable factors like x or y, yeah, have more than one base, be careful to combine only those powers with the same base. Okay, so if you look at this one, multiplying powers with algebraic expression. These are algebraic expression because they consist of numbers and variables. Okay, so all we're going to combine is the x's, not the numbers. The power is this, and this. So the 5 and the 3 are not raised to the power. I'm going to show you. 5x to the power of 4. The 4 does not reach the 5. If it was like this, yes, it would be 5 to the 4th, x to the 4th. But we have 5x to the 4th does not equal 5 to the 4th, x to the 4th. It's just simply that, okay? So parentheses versus not parentheses. So all we're going to do is multiply 5 times 3, which is 15, correct? So the 5 times the 3, 15. the x's have the same base and you have to add the exponents. Make sure you add a 1 here. So I'm going to put that in red. You have to put a 1 if there is no exponent. No exponent. Make it a 1. Okay. All right, let's add our exponents. Just moving that over. I want to make it blue. 15, 5 times 3, x, write it once. 4 plus 9 is 13, plus the 1 is the 14. This is your answer. Okay, let's look at this one. So we have C, D, and C. You can only combine the ones with the same basis. So I'm going to rewrite it. I can do that. So C's are together now, so you can see it better. The 4, the 2, and the 7, you need to multiply. -4 times 2 times 7. Use a calculator. 2 times 7 is 14. 14, it's going to be a negative answer. That 8 times 7, 56, I believe. 8 times 7, 56. So -56 is our leading coefficient. We call it the leading number. The number comes first. Then comes the C's. You can only combine the C's. Yeah. C 3 plus -2 is 1 times D squared, because the 7 is already in here. Yeah, the 7 is already mixed in here. So don't write the 7. Or to make it shorter, -56 C D squared. This is the best way. All right. And last one in this section, I have J, K, and J. So I got to combine my J's. So these two get together times K to the power of -2. The K stays out here. This is a 1. So we have the 12 times 1 times 1 is just simply the 12 is our leading coefficient. The J's, 2 and 1 to the third, K to the power of -2. I want to put this on the bottom to make it positive. You want your powers positive. 12 J to the third divided by K squared. So when you have a 3, 3 is cubed, and 2 is squared. Otherwise, it's power of 4, etc. That's how you say it, okay? So that would be J cubed, K squared. So this would be a good answer right here. So we're going to the next page. And I think I'm skipping that page. So it helps if, I decided if you skip the page, you can cross it out. Well, no, you can write on top skip, because then I know when I check your notes. So we can skip it. Don't cross it out, because who knows, we might do a couple questions on here to review. All right, next page is this one up here, human. So there are 599, page 599, biology. Very interesting to me, the count of your white blood cells, because they are the ones that keep your immune system healthy. So the blood cells, their job, the white blood cells are in your blood, and their job is to keep your body strong and healthy, so you don't have, when you get older, you don't have to fear so much about cancer, heart disease, stroke, if your immune system is strong. So let's read the question. A human body. So by the way, before we start this, I need to go over what's called scientific notation. So let's go to the previous page and make room. I'm going to give you a short review on scientific notation so that you're not totally lost. So let's say I have 5.1 times. The only time you use an X for times is in scientific notation. It's always base 10. And then let's say it's to the power of 3. If the power is positive, you have a big number. If the power is negative, you will have a small number. I'll show you. So the 5.1 times 10 to the power of 3, the 3 tells you how much to move your decimal to the right. So you have 5, 1, and then 2 zeros. You're moving your decimal 1, 2, 3 to the right. So 5.1 times 10 to the power of 3 is the same as 5,100. Put a comma, it's easier to read. Okay, big number means, so I should say positive exponent means big number. But if you have a negative exponent, it means a small number. So by the way, your first number is always a decimal with one number in front, and then comes your decimal point, and then there's some numbers in the back, but it's always one digit here. This is your tens. Yeah, if you have two numbers here in front of the decimal, it's not proper scientific notation. Okay, it's always like that. So let me make up a number. Whew. Let me make up a number. I'm going to say 7.31. You can have more numbers here, but you can only have one number here. The X means time, 10 to the power of negative 4. You know, a negative exponent means it's a small number. So you move your decimal to the left. So add some zeros in the front. Negative 4 means you're moving a decimal 4 to the left. Okay. So start here. 1, 2, 3, 4. Okay, come on, my little machine. Don't wig out on me here. So here's my decimal point. You can add a 0. It helps to add a 0. So this number really equals 0.000731. That's how you, yeah. So scientific notation is used to make short out of big numbers. See how this number is so big? A lot of times you have so many zeros, it would be really hard to write them all out. So the scientific notation helps, and it's used in science apparently, right? A lot. Okay, let's move on to our word problem. Up here, biology. A human body contains about 2.7 times 10 to the power of 4. So that's moving your decimal to the right 4. Microliters, which is, I believe this letter is called mu L. This is the short for microliters of blood for each pound of body weight. So I'm going to underline the numbers. I know I'm going to use this one. Each pound of body weight is important. So let's say your body weight, this is 1 pound, 2 pounds, 3 pounds. Let's say each square is a pound of your body weight. Inside this pound is 2.7 times 10 to the power of 4 microliters of blood. Okay, so this goes in here, and this person is 140 pound heavy, so you really would need 140 of these little squares, and in each one you got 2.7 times 10 to the power of 4 microliters of blood. Okay, each microliter of blood contains about 7 times 10 to the power of 4 white blood cells. So in each of these microliters of blood, in each one of them, you have 7 times 10 to the power of 4 white blood cells. Very complicated to understand. The question is about how many white blood cells are in the body of a 140-pound person. So we're figuring out, and it's a big number, I guarantee you, because these are all big numbers and we're going to multiply them, you'll see. And then we're going to multiply it by 140. So what I'm going to use is called unit analysis. Unit analysis means you can cross-cancel units. You have to write a fraction and then cross-cancel the units. The units you don't want. So let's try that, okay? I can show you 2 ways, and if you're not sure how what happened, I can show it to you in class again in a different fashion, okay? First of all, this right here, I'm just going to write it out so you see. Not that we're going to use this big number, it would be 27,000. Because you're moving your decimal 4 times. It's a big number, right? And this number, just to give you a little heads up, it also gets moved 4. So 1, 2, 3, 1, 2, 3 is 70,000. Okay, just to give you an idea what these numbers look like, all right? But we're not using these. We're going to write our unit analysis fraction. So we're going to start with the first one. It says there's 2.7 times 10 to the power of 4, and you need your units, and these are called mu L, microliters. In every 1 pound of body weight, each pound means 1 pound of body weight. I'll make the units red. We cannot cancel these. These are not named. You see, we're trying to cross-cancel units. This is not going to work, but let's make another one. Times, it's times. We also know that we have 7 times 10 to the power of 4 white blood cells, which I don't have a unit. I'll just call them white blood cells. White blood cells, that's cool. For each 1 mu L, because it says that each microliter of blood contains about 7 to the power of 4. So we know we have for each, and now I have created a cross cancel somehow by making it very tricky. You have to think about it. I can cross out the mu L because I won't need them in my answer. It's not asking about, it's asking about how many white blood cells. So this is the unit I need, white blood cells count. Yeah, so I don't want to cancel that out, but I want to try to cancel everything else out. But I also need to cancel out the pound. So I'm going to say 140 pound for 1 person. Could be you. Now notice that I can cross cancel pound. The cross canceling means it's the bottom and the top, the unit. And it's gone. All we have left is that white blood count per person. You notice that? So now we have to multiply the numbers. So we're multiplying 2.7 times 10 to the power of 4 times 7 times 10 to the power of 4 times 140. correct? So let's write that out. 2.7 times 10 to the power 4 times 7 times 10 to the power 4 times 140. The numbers in front, you multiply, use a calculator. So you're multiplying 2.7 times 7 times 140. Let's see what we get. Use your calculator. 2.7 times 7 times 140. 2,646. Times, and these are the same bases, 10 times 10 to the power of 4 plus 4 is 8. Now this is not a decimal point. The decimal point is here. So if I want to write this in scientific notation, I need to go back and make it 2.6 to have that proper, and I need to adjust that. I'm adding 3 times 10 to the power of, I moved back 1, 2, 3, so I have to add 3 to the 8, it would be 11. So this would be my answer in scientific notation, and it's the number of white blood cells. Now I want to write this number out to show you it's big, okay? There's this many white blood cells in a body of a 140-pound person, which could be you. So I'm going to move my decimal 11 spaces to the right. Or, so I'm going to write or. I start with 2.646. So that makes it 3, and then 8 more zeros. 1, 2, 3, 4, 5, 6, 7, 8. So to read the number, put in commas after 3 from the back. So that's a big number. Or I believe it's 264.6 trillion white blood cells. It's a big number. And we want to keep that. I want to show you a picture of a white blood cell. So let's go. There it looks like, there it is. And I bet these are red blood cells, but I'm not a good science teacher, so I can't be for sure, but I thought this looks real cool. And then it tells me here how to keep your white blood count up, which is important. You want a lot, you want a high number. Eating vitamin C will help regulate the levels of white blood cells in your body. Fruits like lemons, oranges, and lime are rich in vitamin C, and so are papayas, berries, guavas, and pineapples. You can also get vitamin C from vegetables such as cauliflower, broccoli, carrots, and bell peppers. Those are called antioxidant. Now, guys, I know you're young, but I'm telling you now, if you start getting in good habits now, it's going to pay off later. You will thank your body later that it can help maintain what you wanted to do when you're older. So just give you a little inspiration there, okay? Now, this question is not easy. If you need me to go over that in class again, I'd be glad to, and I can show you another way besides unit analysis, okay? All right, let's go on to, I think we're skipping, yep, we're skipping the next 2 pages. So put on top, skip page. And on the next one. And now we're starting, I think the next one is already your homework. Oh, we have one more little, yep, one more little thing. It's multiplying. So we have a second rule in this lesson. Okay, so the second rule, I can write it here. I'm going to say to multiply. Well, we already did that. Oh, now they're talking about fractions. Now, we're not going to do fractions. So anything with a fraction will be skipped. Yep. Okay. Now we're going to the homework, number 13. So that's your first question. It's going to be a little longer, but it's easy question. All right. Is go down your line of notes and see. It's always the same example with the same problem. Example 1 goes with the first few questions. So we don't do 14. Then 15. You multiply the numbers and you add your exponents. Yeah, base 10. Scientific notation is always base 10. Okay. And then you're on the next page. 16. Nope. Cross that off. 17 is 1. And then nothing on that page. Then you go to up here, you're going to do 20. You're going to fill in the blanks. What to see, you have the same bases, so 2 plus what is 11. So you have to find this power. Same with 21, you're finding the blank. 23 and 25. This is your big word problem. Think about a plan. It's just like I showed you, the big white blood cell problem, okay? This is about molecules in the river. So I don't exactly know what a molecule entails. I think it's like an atom, something inside an atom, maybe. I'm not quite sure. I'll probably make a fool out of myself talking about it because I really don't know. But it's something in the tiniest of our how we measure our matter, right? How many molecules does the Mississippi River every minute? And here, write your answer in scientific notation. So you want something times 10 to what power, right? And then it's talking about unit analysis. Maybe you can figure it out with unit analysis like I showed you, or you can try it any other way, okay? And then on this last page, nope, that's it. That's it for homework. And good luck to you. I'll see you later.